So this is Euler's formula, and we're going to use it today to find a complex way to write sine and cosine. Let's start with this. So we know this because we just put in negative theta in here. So we say e to the negative I theta is that. But what is this? What is cosine of negative theta? Well, cosine is an even function, so the negative will be the same as positive. So that's just cosine of theta. Now this one, sine is an odd function, so the negative will just be the same as the negative outside here. So that's minus I sine of theta. Now we got two different equations, we can subtract them from each other. So this is e to the I theta minus e to the negative I theta. Now if we subtract these, we subtract cosine from cosine, that will be 0. And this we subtract negative sign from positive sign, and with the I. So that will just be 2I sine of theta. Now pretty easily we can just divide by 2I, and we get that sine of theta is equal to e to the I theta minus e to the negative I theta divided by 2I. Now instead of subtracting equations, we can also add the equations, and we get that e to the I theta plus e to the negative I theta is equal to, we add these, we get 2 cosine of theta. Now if we add this, we get 0 plus 0. Now we can just do the same trick, and we get that cosine of theta is e to the I theta plus e to the negative I theta divided by 2. Now we know that the tangent of theta is sine divided by cosine, so we have to divide this one by this one. So we get the tangent of theta is e to the I theta minus e to the negative I theta divided by 2. Now we divide this by what is over here, so that's e to the I theta plus e to the negative I theta divided by 2, and this should be 2I. Now we can rewrite this, so we get that this one stays the same, and we have to flip this one. So that's e to the I theta minus e to the negative I theta but then we have to multiply by whatever is down there, that's 2. Now for the bottom part, we get 2I, and we multiply it by what is on the top over here, so that's e to the I theta plus e to the negative I theta. Now we can cancel out the 2, and we're left with e to the I theta minus e to the negative I theta divided by, we multiply by I, so we get I times e to the I theta plus I times e to the negative I theta. Now we can try to find a general formula for the inverse sine. So sine of theta is a. Then what is theta in terms of a? So we can see e to the I theta minus e to the negative I theta divided by 2i is a. Now we can multiply by 2i. E to the I theta minus e to the negative I theta is 2ai. Now we can multiply everything by e to the I theta. So we do e to the I theta times e to the I theta minus e to the negative I theta is e to the I theta times 2ai. Now let's multiply this out. This will be e to the I theta squared, but we can multiply the exponents. So we get e to the 2 I theta. This multiplied by this will be 1. So that's minus 1. And this equals 2ai times e to the I theta. Now this is actually a quadratic equation in terms of e to the I theta. So we say e to the I theta we call that u. So we say u squared minus 1 is 2aiu. Now we can solve this. So we say u squared minus 2aiu is 1. Now we're going to complete the square, so that's u minus ai squared. Now I have to minus ai squared. Okay, this is really bad. And that's going to be equal to 1. Now, we'll leave this as it is, so that's u minus ai squared. Now, a squared is, we'll just do it a squared. I squared is minus 1. And that's 1. Now this is going to be u minus ai squared now plus a squared is equal to 1. U minus ai squared is 1 minus a squared. Now we can take square root on both sides. So u minus ai is plus or minus the square root of 1 minus a squared. Now u is ai plus or minus the square root of 1 minus a squared. Now remember, u was e to the I theta. E to the I theta is ai plus or minus the square root of 1 minus a squared. Now take ln, and we get I theta is ln of ai plus or minus the square root of 1 minus a squared and we divide by I and we get that theta is ln of ai plus or minus the square root of 1 minus a squared divided by I. So now we got the definition of the inverse sine, and I want to give you a challenge. That is, can you find a complex way to write the cosine, the inverse cosine of A?